The Byzantine generalist problem. So blockchains arrived basically quite many years after decentralized consensus protocols emerged. There are many. There have been decades of research on classical consensus mechanisms. One of the main differences is that these classical consensus mechanisms assume a fixed set of participants, and often they also include the existence of an identity system, such that we know who is whom, and we can basically identify the different consensus participants. So we're gonna introduce today the Byzantine generalist problem, not very formally, just on an intuitive level, such that you can understand and make the link between blockchains and traditional consensus mechanisms. So you can see here we have a castle. The castle is guarded by a few guards, and we have quite a few knights, and these knights, they want to attack the castle. So let's assume they arrive from these 4 different directions, geographic directions, towards the castle. And well, at the time they didn't have any cell phones, so they can't really talk to each other. They cannot have a live stream or any other means of communication. So the distance between here, these elements, these knights, is quite far. And here we also assume they can't really easily talk. So how do they attack then? Should they attack? Should they retreat? Should this guy attack, or should they surrender? Right. So it's kind of a problem of they need to. The Byzantine generalist problems is everyone has to know something, like has to know this value x, right? Whether to attack or whether to surrender. But that's not enough. Everyone has to know that everyone knows x as well. And moreover, everyone has to know that everyone knows x. That's the Byzantine generalist problem, which is quite tricky, right? You want to, you kind of want to find this consensus here of what should we do, right? Because if they are not acting in a united action and they are attacking, or maybe 2 of them are attacking, 2 of them are surrendering, that doesn't look too good, I believe, on the battlefield. So if we draw the parallel to payment systems, we can think of it as quite a similar game. So here we have again the 4 knights, and now they don't want to fight, but they want to know who does this coin belong to, right? We have this coin here in the middle, and we kind of want to have a consensus among these 4 knights. Who does this belong to? Well, they are still far away, so they still don't know how to agree before taking an action. Like, for example, if this knight wants to pay this knight with the coin, then everybody has to agree that this coin actually belongs to that knight, right? Otherwise, he wouldn't be eligible to spend that coin. So, if we look at centralized payment systems, we can rather trivially see that this is an easy problem, right? We can solve that. It's basically solvable because we know that this coin belongs to Alice because the bank says so, right? The bank is kind of the ultimate truth, is the ground truth here about what is right and what is wrong. And in a sense, you can think of it like Alice and Bob here. If they want to perform a payment, then since Alice owns the coin according to the bank, then the other participants will also accept that statement from the bank. So to give you a few examples here of such digital payment systems like Pepper micropayments from Revest or eCash from David Chaum, these are typical examples of digital payment systems, like historical payment systems. Now, the double spend protection, so the protection that this coin is spent only once by Alice, is typically a digital signature, so a cryptographic digital signature, where if Alice were to create a transaction, she would sign some amounts of data such that the bank stores a blob of this data and can decide then later whether something is already spent or not, which is the double spend problem. which we will look into later in this lecture as well. Okay, now let's assume we want to move towards a decentralized digital payment system. Now, we don't have a bank anymore, right? We don't have this centralized entity that we have to trust in recording faithfully the balances of the different individuals. Now, we have, for example, a coin here that belongs to Alice, and that's what this knight believes. We also have this knight that is in agreement, and this knight. However, we have here the bad guy, and he says, well, the coin belongs to Bob. So, who's right? And here, if you later want to make a payment, right? If this knight Alice wants to perform a payment, well, in a decentralized payment system, she actually has to perform several transactions, or has to broadcast a transaction, has to make aware different peers about the same type of about the same information. Right? She wants to send, for example, some coins here to Bob, right? Then she wants to pay it here. She wants to pay it here. She wants to send it here, right? I mean, the transaction is sent across the network towards these different peers, and they hope, basically the hope is that everyone should have the final same view of the ledger. If people have a different view of the ledger, then there's no consensus, and the payment system isn't really able to proceed, right? Because, well, we don't have any clear guidance. So what's important is that the blockchain is not equal to blockchain. Right? If you hear blockchain, I really recommend you to pause for a while and think, what kind of blockchain are you referring to? So are you referring to an open and decentralized blockchain, such as Ethereum or Bitcoin, where anybody can join and leave at any point in time? Or are you referring to a permission-based blockchain, where only certain entities are allowed to perform certain actions, which is not necessarily open to everyone? So, as I mentioned in the first lecture, so Bitcoin was first introduced in 2008. So the software was released, and this was done by a pseudonym called Satoshi Nakamoto. We still to date publicly don't know who that is, and that remains a mystery, which is probably quite an interesting concept of a decentralized currency itself. It is a peer-to-peer decentralized currency, which means you have several peers, right, as we just seen in the slide with the knights, that don't have the same view necessarily of the ledger and of the network. It's supposed that there's no trusted third party, but that's not necessarily true. So we will look into this. I mean, there's a paper also, if you want to read more. Is Bitcoin actually decentralized currency? In general, a blockchain is made up of blocks and transactions, and we will look into those in more detail in the upcoming lecture. So thank you very much for watching.